Okay, well, welcome everybody. I'm Brad Treeby. I'm the admissions tutor for the Biomedical Engineering program, which is a course that we started in 2014. We're actually a much older department than that. We started with one of the oldest medical physics programs in the country. And then, of course, due to the recent uptake of an interest in biomedical engineering, we started a brand new course in biomedical engineering. So some of the strengths of our department. So first and foremost, we produce really world-leading and internationally excellent research and teaching. So what does that mean for you as a prospective student? Well, that means that you're going to be taught by the people who are working in the state of the art, and not just working in the state of the art, but defining the state of the art. So some of the lecturers on the course are some of the world leaders in their respective disciplines, covering all kinds of things from medical physics through to prosthetics through to implanted devices. So all aspects of biomedical engineering. The second thing is we're a relatively small department and we have relatively small student numbers by design. So that means we really get to know all of our students. So we have relatively small interactive classes, so class sizes ranging from 20 to 30 students. So we really get to know you all by name, and most lecturers have an open door policy. So by the end of the course, you really will know your lecturers. And the final thing is, being a medical physics and biomedical engineering department, this is quite key. We have a really close network of hospitals that we work with. So that means we work really closely with clinicians and patients so that we're engineering solutions to real clinical problems. We're not operating in a bubble. We have the really excellent network of hospitals. And I'll say a little bit more about that later. So in terms of our department, as I mentioned, we're relatively small compared to, let's say, a big traditional mechanical or civil engineering department. We have about almost 40 permanent academic staff and a large number of postdoctoral and PhD student researchers carrying out research. In terms of undergraduates, we have about 40 biomedical engineering students per year, and there's roughly a 50-50 gender balance. In the third year, medical students from UCL Medical School will join some of the courses, the integrated medical students who choose biomedical engineering as an integrated degree, and we also have MSc students that will join for some of the final year courses. So engineering, of course, we're trying to solve technical problems, we're trying to design and develop new products, and we're building on physics and maths. The difference for biomedical engineering, of course, is that we're also building on things like anatomy and physiology and so on, so we can design and engineer products and technical solutions related to healthcare and well-being. So the research in our department, which mirrors the teaching, can kind of be broken down into two major areas. That's medical imaging and medical therapies, and within that, we teach a whole range of things, from different imaging techniques to prosthetics to biomedical engineering to physiology. So basically you learn how an engineering device works in terms of its electronics and software components and embedded components, and then how to apply that technology to the human body. So of course you need to know a little bit about both disciplines to be able to design effective solutions. In terms of the degree program, so the biomedical engineering degree is part of the UCL integrated engineering program. So this is a really innovative and award-winning undergraduate teaching framework, which is really exciting. And for me, there's two key parts to this. So the first is it really celebrates the multidisciplinary nature of engineering. And the second is you're going to engage in some practical engineering from the very beginning of your course. And I'll say a little bit about that on the next slide. So in terms of the course structure, we offer both BEng 3-year degrees and MEng 4-year degrees. They are identical up to the end of year 2, and you can swap between them. So you can change your decision about whether you want to take a 3rd year or a 3-year or 4-year course. The differences start in the 3rd year, where if you're taking a BEng course, your research project will be a personal project, and if you're taking your MEng, then this will be a group project, and you'll take a personal research project in your final year, along with some additional options across medical physics and engineering. The blue highlighted courses here are courses that are taken across the whole of the integrated engineering program. So these are skills in engineering challenges. You'll cover things like ethics, professional skills, design skills, the design life cycle, and so on, along with things like mathematical modeling. The white courses here are the courses that are specific to our department. So there's a number of them. So in the early years, you cover everything from medical instrumentation in devices to learning something about the human body, cardiac engineering, and so on. I just want to highlight a few things in this course. The first being the scenarios. So this is a really exciting and innovative way to learn. So across the first 2 years of your course, you'll do 5 of these. And basically what happens is you stop all your courses for an entire week and you've set a really challenging problem to solve on day 1. And then on day 5, you need to present a device or piece of software or so on that you've designed over that week within a group to solve that problem. So this is a couple of examples you can see on the screen of 2 different scenarios that we've offered in the past. The first one is one that's offered in year 1. So that's using your mobile phone and the camera and the LED flashlight to design a pulse rate detector app. So this is really exciting because lots of students have never done app programming before. So you're thrown in the deep end, and then by the end of the week, you need to present your device, and the performance of that to measure your heart rate or your pulse rate is then compared against a ground truth using a pulse oximeter. The second one shown on the right is another scenario where you design some wearable technology for marathon runners. So these are just 3 examples of what people have come up with: a hydration monitor, a body temperature monitor, and a gait monitor. And all of these are using low-cost programmable electronics to design these wearable tech. So in my opinion, at least, there's actually never been a more exciting time to be a biomedical engineer, especially with the access that we now have to all the rapid prototyping devices, so things like 3D printing and laser cutting, other additive and destructive manufacturing techniques. So it's really, really easy to go from an idea to a prototype extremely quickly. And in my lab, in my group, in the biomedical ultrasound group, we'll often have an idea, and then we'll be able to 3D print a concept design or use a low-cost programmable electronics like Arduinos to come up with a prototype extremely quickly. And when I started engineering 15 years ago, that just wasn't possible. So you'd have to wait for a workshop to build you something. So it's a really extraordinarily exciting time to be an engineer. Another example of this scenario-based learning that we offer as part of the engineering program at UCL is this How to Change the World. So this is an immersive 2-week program that you take after your 2nd year of study. And it's taken across 11 UCL departments, so something like 750 students. So you're really exposed to the multidisciplinary nature of engineering. And you're presented with a really broad, open-ended societal challenge to solve. So this could be something like supplying energy services to rural Africa, or finding solution to congested transports in urban centers, and so on. So really broad challenges. And then you have facilitated workshops, so you can really touch on the, as well as the engineering aspects, you can touch on the social and political and economic dimensions of the problem, which are of course really important to being an engineer in today's society. And then within your teams, you come up with really innovative design concepts that you then showcase at the end, and you pitch your ideas to a panel of experts. So it's another example of the kind of scenario-based learning that's part of the IEP at UCL. You also have the opportunity to take a minor stream. So this is 3 modules that you take out of the prescribed courses in your first 3 years. There's quite a few options you can take. At the moment, we offer something like 19 different minor streams. So these cover everything from languages through to entrepreneurship. Some of the most common ones that our students take programming, entrepreneurship, and intelligent systems. So that's an option that you can take, of course. In terms of a typical week, in our department, in our course, biomedical engineering course, you'll spend something like 12 to 16 hours a week of lecture time, maybe about 6 hours a week in the lab. So that could be as part of project work or as part of coursework. You'll spend some time doing problem-based learning classes, and then you'll also have some time with personal and academic tutors. So let me say a few words about tutoring. So the tutorials are there to provide pastoral care for the students, and we think this is really important. So you'll be placed into a tutorial group that will have about 8 students with a mixed year grouping. So there'll be students from first and second and third and fourth year. And each time you meet your tutor group, you'll cover different topics. So for example, how do I get a summer internship? Or what's the best way to find accommodation in second year? Or, you know, those sorts of pastoral support. So they can be really, really handy, especially passing knowledge down from the more senior students to the more junior students. There's also a second scheme, which is organized by the BME students in their second and third and fourth years. So this is for students in the first semester, the first term, where all first year students are assigned an older mentor who can really help you find your way around UCL and around the course and just navigate living in London and going to university and so on. So one of the real strengths about UCL is our really close links with UCL affiliated hospitals. So on campus, literally across the road, is University College Hospital, which is really, really big teaching hospital. So we have very strong links, but also with lots of other hospitals in the trust and across London. So some of them are listed on the screen there. So what does that mean? That means we work side by side with doctors and other health professionals, and they contribute to the learning. So, for example, one of the courses I teach on biomedical ultrasound, consultants from the hospital, from UCH, come across and give context to the engineering and physics that we're teaching. So how is the device used? What are the requirements? And so on. Another example is shown on screen there, to do with orthopedics, where these students went to see a hip replacement surgery. So again, as part of your learning, you really get to see the clinical coalface, as it were. You're not doing your learning in a vacuum, which is absolutely critical when you're working at this interface of engineering and biomedicine. One of the options we offer for people studying the MEng degree, that's a 4-year degree, is you can take your 3rd year abroad. So there's a big long list of universities that you can study across the US and Europe and further abroad. So you can take a year abroad if that's something that interests you. And of course, one of the draw cards of UCL, beyond its really impressive research and teaching track record, is living in London. So it's a fantastic city to live in if you're not already from here. It's really vibrant. So many things to do in terms of the arts and music and so on. We have a really, really active student union. So there's lots of things and lots of societies that you can join, everything from rowing to knitting to sports. There'll be a society that covers your interests. And we also have a really social department. So we have lots of staff-student mixers, student activities, and so on. So there'll be lots of opportunities to make new lifelong friends and connect with our department more broadly. So what can you do when you graduate? In my opinion, you can do anything. So one of the key things that the engineering program at UCL is teaching you is how to draw on your skills and knowledge to solve new and unseen problems. So that really places you at the forefront of graduates in terms of where you can go afterwards. So our graduates have gone on to do all kinds of impressive jobs, from being clinical scientists in the NHS, to working for medtech startups, to working for graduate schemes at big medical companies. Some have gone on to do PhD programs and work for other medtech in the medtech industry. So really lots and lots of different things that people have gone on to do.